All right, hello everyone. We're going to go ahead and get started with our exam 1 review. Now, these are questions that I have chosen that I think will be helpful for you to see and practice before your Unit 1 exam. So, without further ado, let's go ahead and get started. So, question number 1, we want to use the Venn diagram to answer the following questions. And we have the Venn diagram here. We have 3 sets. We have the sets dogs, humans, and lizards. And we have a universal set there. So for A, we want to know which set cannot be found in a Learn NC office. So we do see that there is that attribute right here found in Learn NC offices. Then we want to know which sets have 4 legs. There's another attribute here. It says have 4 legs. We want to know how many sets are animals. We see here, it says animals here in the center. And then we want to know what characteristics do humans, dogs, and lizards not have. So our 3 sets are dogs, humans, and lizards. So we want to know what they don't have. So we're looking to these characteristics that are outside of our sets. Now, looking at our sets here individually, we have humans here, right? Humans in our whole set here, right? They're mammals. Those are also animals. We can eat bugs. We can be found in a Learn NC office, whatever that is. Can run for president, and we have 2 legs. Then over here, we have our set for dogs. Dogs have fur all over. They are mammals, which are animals. They may also eat bugs, and they have 4 legs. And then in our set for lizards here, we have lizards have scales. They're also reptiles. They do have 4 legs. Apparently, they can be found in a Learn NC office. They are animals, and they may also eat bugs. So those are all the attributes we have in our 3 sets here. And then on the outside of our 3 sets, we have fins. Dogs, humans, and lizards don't have fins. Can breathe underwater. Dogs, humans, and lizards all can't breathe underwater. And can fly. Dogs, humans, and lizards all can't fly. So those are all attributes that they do not have, so they are not within the circles within the sets. So we're going to try to answer these 4 questions here using the information from our sets. We're going to go ahead and we're going to write these down separately. So we have our problems here. So we're going to go ahead and we're going to write these down. So our first one, which set cannot be found in a Learn NC office? So that found in a Learn NC office, right? That's that attribute right there. So the sets that we're kind of looking at, right? We have this in humans, and that Learn in NC office is also found in the set for lizards. So the set that it would not be contained in would be our set for dogs. So that is the set that is not found in the Learn NC office. All right, then our next one, which sets have 4 legs? So we're looking at this attribute right here, which set has 4 legs. So we definitely see that the set of dogs has 4 legs. That set contains that characteristic. And so does the set of lizards. Lizards also contains that characteristic. And humans does not, we also know that humans don't have 4 legs. So that helps as well. So then we can go ahead and write this down. Which sets have 4 legs? Dogs and lizards. All right, then how many sets are animals? So we have that characteristic there, animals, right there in the center. The one in the center typically means that all sets contain that. We do see that, yes, dogs are animals. Animals are contained within the set of dogs. Lizards are also animals. Animals are contained in the set of lizards. And also humans. Humans are also considered animals, also contained in the set of animals. So how many sets are animals? Just be all 3. So we have all 3 sets are animals. All right, then our last one. What characteristics do humans, dogs, and lizards not have? So all the characteristics that they do have are located within their circles or their sets. So the things that we are looking for are the things that are not within the circles. Which of these characteristics here have fins, can breathe underwater, and can fly? Those are characteristics that all three of them do not have since they are not located within our three circles. All right. So that's number one. So let's go ahead and go back to our slides. So we can go ahead and go to number two. All right, number two. We want to rewrite each set in the given form. So A, this is currently in our set builder notation. So this is talking about an element and then listing a property of that element. So we're talking about X, and then we're saying that X is a natural number and 25 is less than X, which is less than 30. Then we want to rewrite that to be in roster method. Roster method is listing out the numbers within curly braces and putting commas in between. Roster method is what B looks like. So B, we have, right, curly braces with 12, 18, 24. That's the roster method. So that's B, 12, 18, 24. And we want to rewrite that into the descriptive method. The descriptive method is basically rewriting it so that it's in kind of like plain English. So we're describing the set as opposed to writing it in set builder notation or the roster method. So, all right, let's go ahead and write out our answers. So we're going to rewrite each set into our given form. So starting off with A, we have X, where X is a natural number, and 25 is less than X, which is less than 30. So our roster method, right, we write our curly brace, and then we list out the numbers. So by saying X is a natural number, we want to remember that a natural number is going to be a counting number, so a whole number. A natural number is a whole number that is positive, that is not zero. So essentially 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so on. So it's a whole number, it's positive. So we want a whole positive number. And we're saying that X is greater than 25 but less than 30. Now remember, these are strict inequalities. Since we're saying that X is greater than 25, it cannot include 25. So we have to go to the next higher number than 25, which will be 26. Then we say X is essentially every number in between 25 and 30. So we would go 26, 27, 28, 29, and then we would think, well, do I include 30? We have X is less than 30. It's a strict inequality once again. It would not include 30. We would only include 30 if we had a non-strict inequality, meaning that it was less than or equal to, so it had the little line underneath as well. So since we do not have that, we're saying that X is strictly less than 30, so it cannot equal 30. And 29 is the number that is closest to 30, that is a whole number. And so that would be our answer. That would be our answer in roster method. So it would be 26, 27, 28, and 29. All right. Now for B, we have roster method. It's 12, 18, and 24. Now we want to try to rewrite this as the descriptive method. So we're going to try to describe what we see going on here. So we're going to scroll down a little bit here. So we look at 12, 18, 24. We definitely see, okay, they're even numbers, which is good. But if we just start off by saying that they're even numbers, there are a lot of other even numbers that we're kind of avoiding, between 12 and 18. There's also like 14 and 16. And then between 18 and 24, there's 20 and 22. So they are even numbers, but it's even more than that. There's something else with them. So we want to keep that in mind. Something that we kind of maybe want to start with is that they are whole numbers. They are positive and they do not include zero. So we can start off by saying that they are natural numbers. It's kind of a first place to start. So with our descriptive method, we can say that x, or our numbers here, is a natural number. So x is a natural number. Or instead of saying x, another thing you could say is we could say the set and then we can say the set of natural numbers. So you have some options. You can say x is a natural number. That kind of leans it a little bit more towards like set builder notation by saying x, which is fine. That's still the descriptive method. Or you can say the set of natural numbers. So you have some options. It can be kind of up to you. I like to say the set of natural numbers since that is typically what we're looking at. We're looking at a set that is in roster method right now. So we're describing this. We're saying the set of natural numbers. And now we want to describe it. We definitely have a low number of 12 and we have the high number of 24. So what we could do, and since we are describing this, just as in English, there's so many different ways of describing the same thing. And as long as you are accurately describing that thing, that's all that really matters. We're not necessarily trying to like perfectly describe it in one single way. There's not one perfect way of doing this. We just want to do it accurately. So maybe I would say, okay, well, the lowest number is 12 and the highest number is 24. So I'm just going to include those. So I would say, okay, this is the set of natural numbers where, you know, the lowest number is 12 and highest number is 24. Well, the way we would write that with our inequalities, right, is that we would have x greater than or equal to 12 and less than or equal to 24. So we could say something like that. So we'd say the set of natural numbers where x is, we're going to start with the greater than, or equal to 12 and less than or equal to 24. Okay, so that's a good place to start. We have the set of natural numbers. X is greater than or equal to 12 and less than or equal to 24. But by establishing that, that would be 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So that's a lot more numbers. So because our values are only 12, 18, 24, we need one more thing to really specify why is it 12 and 18 and 24. And we already said that even doesn't, it's not that great of a descriptor because that would be 12, 14, 16, 18, 20, 22, 24, and we're still missing some of those numbers. So we want to think of what these numbers have in common. And if you have not thought about it or not realized it by now, that is okay. The thing that they all have in common is that they are all multiples of 6, or they are divisible by 6. You could write it either way. You could say they are multiples of 6 or divisible by 6. Either way, it means the same thing. So this is the set of natural numbers where x is greater than or equal to 12 and less than or equal to 24, and x is multiples of 6 or divisible by 6. Either way, you can write that. So we're going to go ahead and we're going to say, and x is divisible by 6. So this makes it so that I'm saying, okay, so every natural number that I pick between the values of 12 and 24, including 12 and 24, has to be a number that is divisible by 6. So then that was like, oh, okay, so that's 12, 18, and 24. So that's how we can get to our method there. That's how we can get to our roster method of 12, 18, and 24. I can give you one more example of something that would also be okay. Just another way of saying it. So like we said, instead of saying the set of natural numbers, you can say like x is a natural number, right? You can say that instead, so we'll say that. So we can say x is a natural number. You do want to establish that it is a natural number. If you don't establish it's a natural number, then in theory you could have like decimals. You like definitely don't want that to happen. So you do want to establish that it's a natural number. And then a little bit more casually, we could say like, oh, it's between these numbers. But by saying between these numbers, we're inherently most likely not really including those numbers. So if we say it's a natural number between these two numbers, when we say between, we want to kind of widen that range. We don't want to say between 12 and 24. We want to widen that range maybe just a little bit because we want to include 12 and 24. And the way we include 12 and 24 is by saying the whole like greater than or equal to or less than or equal to. And so if we want to avoid using that phrasing, we want to like widen the range just a little bit. So we could say x is a natural number between, and maybe we can just widen it by 1, between 11 and 25. So we kind of went down by 1 from 12 and up from 1 from 25. So x is a natural number between 11 and 25. That is a multiple of 6. We can add that. So it makes it a little shorter, but we're essentially saying the same thing. It's a natural number, it's between the certain range, and it's a multiple of 6. So by saying it's between the values of 11 and 25, we know, okay, now I have a range of numbers, and it's now a multiple of 6. So then I'm like, oh, okay, well, 6, that can't be in it. Okay, 12. Oh, 12 can, 18, 24, and then we get to 30, and 30 can't be in it anymore. So there we go. That's two different ways of using the descriptive method to describe our set. So there we go. That was number 2. So let's go ahead and go back on to number 3. All right. So for number 3, we're going to determine if each set is equal, equivalent, or neither. So for A, we're saying that A is the set of odd natural numbers greater than 12 and less than 20, and B is the set of natural numbers greater than 18 and less than 23. So here, once again, we see the natural numbers thing, right? Positive whole numbers. And we have our kind of established range, greater than, less than. B, we have A is the set of natural numbers greater than 15 and less than 20. And B is 16, 17, 18, 19. So now we kind of see the mixture of different methods. So A was 2 sets in the descriptive method. B is 1 set in the descriptive method, and the second set is in the roster method. And C, we have A is the set of DFG, and B is the set of GMQZ. So that's 2 sets in the roster method. So we're going to try to compare. We'll see if they're equal, equivalent, or neither. Before we get started, we want to just remember equal means that they have the exact same elements and exact same number of elements. Equivalent means that they have the same number of elements, but the actual elements don't have to be the same. And neither would be that they don't have the same elements and they also don't have the same number of elements. So that's the difference between them. If something is equal, it is also equivalent. If something is equivalent, they're not necessarily equal, but nothing can be equal and not equivalent. Because if they're equal, that inherently means that they're also equivalent. Just a little note. So, all right, let's go ahead and work on this one. So for A, we have that our set A is the set of odd natural numbers greater than 12 and less than 20. So let's kind of establish our set of A first. So it's odd natural numbers. Okay, so positive whole numbers that are odd. Cool. It's greater than 12, less than 20. So greater than 12, it's not equal to 12. It's odd numbers anyway, so we wouldn't include 12 anyway. But the next number would be 13, and 13 is odd. Then our next odd number would be 15. Then our next odd number would be 17. Our next odd number would be 19. And our next odd number would be 21. But we were told that the set has to be less than 20. So that means that set is done. So our set A is the numbers 13, 15, 17, and 19. One strategy that I use when I'm determining if sets are equal or equivalent or neither is to transfer everything into the roster method. The roster method is the easiest way to see if they're equal, equivalent, or neither because you can then count the elements much faster and easier. All right, so now we're going to go ahead and we're going to find the second set in this problem. So it says that B is the set of natural numbers greater than 18 and less than 23. So once again, we see that it's greater than 18, not greater than or equal to 18. So we can't start at 18. We have to go to the next number, which is 19. So we'll start at 19. And this is the set of natural numbers. It doesn't specify odd or even, so we'll just go by 1. So we're starting at 19, and then we go to 20, 21, 22, and then our set told us that it has to be less than 23, not less than or equal to 23, which means that we cannot include 23, and we're done at 22. So if we look at our two sets here, right, our set A is 13, 15, 17, 19. B is 19, 20, 21, 22. They do not have the same elements. They don't share the same. The only element they share is 19. They don't share all 4 of the same elements. But they both have 1, 2, 3, 4 elements. 1, 2, 3, 4. Which means that these are equivalent since they both have 4 elements. So that would make them equivalent sets. So that's how you can tell. So all right, let's go ahead and do our next question. We have A as the set of natural numbers greater than 15 and less than 20. And B is 16, 17, 18, 19. So B is already in roster method, so that's good. We don't really have to do anything for that one. We'll just compare it to our set A. But we do have to find set A first. So it's a set of natural numbers greater than 15 and less than 20. So, right, it's not greater than or equal to 15, so we have to go to the next number up from 15. So starting at 16. And it's natural numbers, so it's the whole counting numbers. So we'll go 16, 17, 18, 19, and it's less than 20, not including 20, so that's where we'll stop our set. Then set B was said to be 16, 17, 18, and 19. And we can look at this and we can tell, yes, they are equal. They have the exact same elements. They also have the exact same number of elements. They both have 4 elements, and those 4 elements are exactly the same, 16, 17, 18, 19. So because of that, that means they are both equal and equivalent. So they are equal and equivalent. Primarily, they are equal. If you had to like pick one for some reason, they are equal. Technically, they are considered equal and equivalent. So we can put that and equivalent. We can put that and equivalent kind of in some parentheses there. But they are equal, which is also considered equivalent. So you see that listed a lot where it'll say equal and equivalent. But primarily they are equal, which means they're also equivalent. So there we go. So then we'll go on to this last one. This one, we don't really need to write out. They're already in roster method, and we could probably tell pretty quickly. We have A is DFG, and B is GMQZ. We see here we have 1, 2, 3 elements in A, and 1, 2, 3, 4 elements in B. They don't have the same elements either. They don't have the same number of elements. So this one would be neither. They are neither equal nor equivalent. So All right. Our sub number 3. Let's go ahead and go on to our next problem. All right, so number 4, the following information was for a 150-person survey. We're going to use the table that we have to fill out the Venn diagram. So that's going to be the first thing we do, is we want to fill out the Venn diagram. We have a couple blank spaces. Then we're going to answer the questions based on our Venn diagram. So A, how many people only had nausea? Then B, how many people did not have nausea or drowsiness? So this first question here, how many people only had nausea? That's an important specification, because if we look here at our table, we have, right, this was a 150-person survey. Our number of participants was that 84 people had drowsiness, 67 people had nausea, and 39 people had both nausea and drowsiness. So if we added these numbers together, these 3 numbers will add up to more than 150. Which you'd be like, oh my gosh, how did that happen? I thought this was a 150-person survey. The things that these do not specify is that these are not specifying that they are not only drowsiness, not only nausea. So it's saying that for drowsiness, 84 people had drowsiness. It's saying that this entire circle here counts for 84. And same thing for nausea. 67 people had nausea. This entire circle accounts for 67. But then we're saying here how many people had both nausea and drowsiness? 39 had both. And the overlapping part in the middle is that part that is considered both. So 39 goes in the middle here, but remember the whole circle, like for nausea, adds up to 67. 39 is already accounted for. So you have to find the leftover number. So when they say how many people only had nausea, that's because in this crescent moon area right here, those are the people that only had nausea, not also having drowsiness. So that's where the language of these types of problems do come into play. You have to be very attentive to these problems when it says only, what only had this, only had that, because those will be big hints as to what you're really trying to solve for and what you're really trying to find. So let's go ahead and do this problem together. All right, so we're gonna go ahead, we're gonna fill out our Venn diagram first, and then we'll be able to answer the questions more easily that way. So we have our table, right? We have had drowsiness, 84, had nausea was 67, and then had both was 39. We know that the having both is that overlapping part in the middle, so we know that that middle portion, that is 39. Then we're saying that, starting off with having drowsiness, this whole circle here needs to equal 84. And right, 39 is already accounted for. So we're going to figure out how many people had drowsiness only. We're going to do 84 minus 39. That's going to be that only drowsiness variable there. So we use a calculator or brains, whatever. And we would get that 45 people had only drowsiness. And if we add them together, 45 plus 39 equals 84. So that checks out. 84 people in total reported having drowsiness, but 39 of them also had nausea. So now we're going to do the same thing with nausea. So we're going to find nausea only. So we said 67 had or reported having nausea, and 39 of them, right, also had drowsiness. So we're going to subtract that 39 from the reported 67. So, right, brains, calculators, whatever, we subtract 39 from 67, and we should get 28. So 28 of them had nausea only. So we've been able to answer or fill out our 3 sets now. Now we want to fill out this last one right here. How many people didn't have any symptoms? We know that the total amount of people surveyed was 150. So we know that that's our total. Now our reported symptoms should be the total of the 3 that we've added together. So total symptoms, we're going to say total reports of symptoms, we're going to add these 3 values. So that's going to be 45 plus 39 plus 28. So we're going to add those together. I'm going to erase those. I'm going to erase all that too. So we are trying to figure out how many people reported having symptoms in general. So we add all those values together, and if we do, we end up with 112. So 112 people reported having drowsiness or nausea or both. So reported having symptoms generally. So if we want to figure out how many people reported having no symptoms, we would say that we would subtract the number of people that had symptoms from the total. So no symptoms would be our total minus the number of people that had symptoms, which 150 minus 112 would be 38. So that's how we can fill out our Venn diagram. So now we can go ahead and we can try to answer our question. First one we had was how many people only had nausea? So right, only having nausea is that value right there. Only having nausea meaning that they had nausea but not drowsiness. So it's this kind of crescent moon shape there. That's only having nausea. So that's 28. Then we want to know how many people did not have nausea or drowsiness. So that last number that we found, that's going to be the not drowsiness, not nausea. We called it just having no symptoms, but just meaning no drowsiness, no nausea. They're outside of the sets, meaning that they did not have those symptoms. So the number of people that did not have nausea or drowsiness was 38 people. So there we go. So filling out, in these types of problems, filling out your Venn diagram first makes answering the questions just that much easier for the rest of your problem. So all right, we're going to go ahead and go on to our next one. All right, so for number 5, we have in a standard 52 card deck of playing cards, what's the probability of pulling a king? What's the probability of pulling a heart card? What's the probability of pulling a king or a heart card? So for this problem, we actually have like a little table here, and it just kind of maps out all the different cards in a standard playing deck. So all of these cards that we see here, this all adds up to 52. There are 52 of these cards. It has the red cards, the hearts and diamonds. It has the black cards, the spades and clubs. It has all of the different value cards. So we have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we have the jack, queen, king, which are considered face cards. So let's go ahead. This is a probability problem, so we can go ahead and work this one out. So our first one that we want to do is what's the probability of pulling a king? So our kings are all here along the side. Right, there's 52 cards in the whole deck. And there's only 5 ways you can get a king. You can get a king of hearts, a king of diamonds, a king of spades, or a king of clubs. So the probability of pulling the king is the number of opportunities out of the total. So you have 4 opportunities out of the total 52 cards in the deck. We do want to answer these as simplified fractions though. So 4 out of 52 can be simplified. 52 is divisible by 4, so you can divide the top and bottom by 4. So we can actually put this into a fraction where it looks like 4 over 52, like that. And then we can divide by 4 over 4. And this would leave us with 1/13. So our probability of pulling a king card would be 1 out of 13, or 1/13. All right, then our next one, what's the probability of pulling a heart card? So now we're looking at the heart cards. So our heart cards are any one of these. So, if you know how many cards are in a suit, then you already know this. But if you don't already, then you can count them. We have the table, so we can just count them up. There is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 cards in a suit. So there are 13 heart cards. So there are 13 opportunities out of the 52 cards in the deck to pull a heart card. So there's 13 out of 52. Now, just like before, we want to simplify this, and 52 is actually divisible by 13. So we can divide by 13 over 13. And this would give us 1 over 4. This makes sense. There are 4 suits in the deck. They're all even, so pulling a heart card would be a 1/4 chance. But then we have it. So pulling a heart would be 1/4. Now, our last one here is that we want the probability of pulling a king or a heart card. So now we have king or heart. So now we have options. So now we're like, okay, I'm okay with pulling any one of the kings. The king of hearts, the king of diamonds, the king of spades, the king of clubs. Or I'm okay with pulling any of the heart cards, which are, right, ace through king of hearts. But one thing that hopefully you noticed was that the king of hearts was just highlighted twice. So the king of hearts is a king card, and it's also a red card, or it's a heart card. So we can't just add them together. We can't just say, well, the king is 4 opportunities and the heart is 13 opportunities, so that makes 17 opportunities. It's not 17 opportunities because you've just counted the king of hearts twice. There's only 1 king of hearts card. So one way, since we have the table, one way we can do this is that we can just count, right? We know that there's 13 across for the heart card. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We only want to count it once. 14, 15, 16. So there are 16 opportunities to pull a king or a heart card. So since this table was given to us, that's one way that we can do it. We can't just count. Another way that you can do it is to just remember that you can't count something twice. So the heart cards, right, there's 13 of them. There's 4 king cards, but there is the king of hearts. And so you counted it twice by adding the 4 and the 13. So you would subtract 1. 4 plus 13 is 17. Subtract 1 for the whole counting twice thing. That makes it 16. So that's another way that you could go about it if you don't have a table or if you don't want to create a table. All right, then once you have it, right, we want to answer as a simplified fraction. 52 we already established is divisible by 4, and so is 16. So we're going to divide by 4 once again, and that will give us 4 over 13. So the probability of pulling a king or a heart card is 4 out of 13, or 4/13. So, all right. Let's go ahead and go on to our next one. All right, so for number 6 here, we have below is the table for the hottest recorded temperatures for 18 cities throughout North America. We're going to use the table to complete the grouped frequency distribution, and we're going to create a histogram. So we have our table here. We have our temperatures. We have 113, 116, 105, 114, 109, 106, 95, 111, 115, 102, 108, 98, 101, 99, 110, 112, 117, and 118 finally at the end there. All right, so what we are going to do is that we are going to rewrite this and create the grouped frequency distribution, and then we'll use that to create a histogram. So let's go ahead and do that. All right, so here we have it. One thing is I had a little typo, so I had to fix that in the table there. But here we have our temperatures. And then we also have our table all set up, and then we have our histogram set up for us as well. So we're going to go ahead and start figuring out our frequencies. So for first group here is 95 to 100. So we're going to go through all of our temperatures, and then we're going to cross out anytime we see a value between 95 and 100, including 95 and 100. So we go across our first line here, nothing. Oh, we get here, okay, 95, cross that out. And, oh, 98, that's another one. And 99. And that's it. Okay, so that means that we had 3 for our frequency from 95 to 100. Now we can go on to our next one. So we have 101 to 106. So we'll cross out anytime we see 101 to 106. So here we go. Okay, now you see 105. And then we see 106. We see 102. And we see 101. And that's it. So that's 1, 2, 3, 4. So it's a 4 frequency. All right, then we go on to our next group. That's 107 to 112. So following along here, we have 109. And then we have 111. We have 108. That was our typo. We have 110. And we have 112. And 107. So that's 1, 2, 3, 4, 5, 6 frequency there. And then we'll do our last one. So this one, we can really just count. We don't even really need to like cross them out anymore since they're the only ones not crossed out. We would do 113 to 118. We just want to verify that they do work. Yes, 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 and yes. So that's 1, 2, 3, 4, and 5. So then we have our frequencies 3, 4, 6, and 5. So those are going to correspond to our frequency on our histogram. Now you can color, I kind of like color coded them in theory, but we don't have to color code them. You can if you want though. But so our first one, our 95 to 100, that's got the frequency of 3. So we're going to make sure that we draw our little bar here at 3. You can color it in if you would like, you know, kind of shade in just a little bit there. Then our next one is going to be 4. So from 101 to 106, the frequency was 4. shade that in just a little bit. Then from 107 to 112, it was 6. So it goes all the way to the top. Shade that in. And then lastly, our last one, 113 to 118, is 5. So we'll go right to the end there. Shade that in a little bit. And there we go. So that's how we can create our grouped frequency distribution table, and then we can create our histogram corresponding to our frequency distribution table as well. And there we go. So that wraps up number 6. Let's go ahead and go on to our next one. Ooh, skipped it. Okay. So for number 7, the following table details the length of time the drug thalidomide, not great at pronouncing that one, can extend a myeloma patient's life. Based on the table, use the midpoint of each data class and estimate the mean survival time for each patient, or for the patients. We're going to round this to 1 decimal place. So we have survival time in months, and then the frequency. So in months, we have 0 to 9, and the frequency is 5. 10 to 19, the frequency being 8. 20 to 29, the frequency being 6. 30 to 39, the frequency being 2. And 40 to 49, the frequency being 3. So we're trying to find the mean survival time based on a chart where instead of having a value for time, we have a range. And this is also the grouped mean. So we have frequency for the mean as well. It's not just a list of values. We have a frequency and we have a range. So we'll need to use the midpoint for our range, and we'll need to use the frequency in addition to that to figure out the mean survival time, or the mean value for our table. So let's go ahead and work on that. All right, so here we have our table once again. So our first thing that we're going to do is we want to find that midpoint of each of our ranges. So we can find the midpoint for each range by adding the 2 values and dividing by 2. So our 2 values for the first one is 0 and 9. So we add 0 and 9, and then we divide by 2. So 0 plus 9 is 9 divided by 2. That's going to be 4.5. Then for that second one, 10 plus 19 divided by 2. That's 29 divided by 2. And then we can find that decimal as well. That's going to be 14.5. Same thing, 20 plus 29 divided by 2. That's 49 divided by 2. That's 24.5. Now you may notice the pattern by this point, and you could probably fill out the next 2 if you'd like. We're still going to do them together. We have 30 plus 39 divided by 2. That's 69 divided by 2, which would be 34.5. And then lastly, we have 40 plus 49 divided by 2, which is 89 divided by 2, which is 44.5. So we found all of our midpoints. So now what we're going to do is we're going to multiply those by their frequencies. So we're going to multiply by frequency. So our first frequency, right, was 5. Then we had 8, 6, 2, and 3. So we're going to do 4.5 times 5, 14.5 times 8. I guess we can just go across like that. 2.5 times 6, 34.5 times 2, 44.5 times 3. So that's what we're going to be multiplying together. And we can use our calculator to multiply these out to get these values. So 5 times 4.5 is going to be 22.5. Then 8 times 14.5 is going to be 116. 6 times 24.5 is going to be 147. 2 times 34.5 is going to be 69. Then we have 3 times 44.5 is going to be 133.5. So now what we're going to do is we're going to take all of these values and we're going to add them all together. So we're going to take the sum of the midpoint times frequency. So we're going to take that 22.5. We're going to add that to that 116 plus 147 plus 69 plus 133.5. So we're going to figure out what those add up to. So calculators, right, or brains, we can add those together. And this should give us 488. Then what we're going to do is we are going to divide that value by the total number of frequencies. So we're going to divide 488 by the total frequency, which we can add that up. That's 5 plus 6 plus 8 plus, I guess I switched those, 5 plus 8 plus 6 plus 2 plus 3, which all those equal 24. So we're going to divide the sum of our midpoint frequencies, which was 488, by the total frequency, which was 24. We're going to round this to one decimal place like it said in our problem. And we should get 20.3 months. And that would be our answer. So that's our process when we do grouped means. And also whenever we do midpoint, whenever we have like ranged means as well, we have to use the midpoint. So that's how we can do that, right? You're going to pick the midpoint of your range, you'll multiply by the frequency, you'll take the total of all those values, you'll sum those values together, divide by your total frequency, and that should give you your mean for your grouped data. And so there we have, that was number 7. So we're going to go ahead and we're going to do our last problem, number 8, together as well. All right, so our last one, number 8. On a satisfaction rating survey of Macy's customers, they rate their experiences from 0 to 100. And here are some of the ratings: 37, 48, 77, 37, 24, and 95. We're going to find the mean, median, mode, mid-range, and standard deviation if possible. It is possible, and we're going to do it. But so here are those values. So we're going to go ahead and we're going to find all of these things that we're being asked for. So let's go ahead and go on over to do this together. All right, so we're going to start with the mean. So the mean that we just did on that last problem, that was a more difficult version of the mean, right? That was the ranged and grouped mean. For this mean, whenever you just have data points, the mean is adding them together and dividing by the number of numbers. So for this one, we're adding together, right, 37 plus 48 plus 77 plus 37 plus 24 plus 95, and then we divide by the number of numbers, which there are 1, 2, 3, 4, 5, 6. So there are 6 numbers that we're using here. So we're dividing by 6. So we add the top, we can use calculators or brains, right? So we add the top up and we should get 318, which is being divided by 6. And so we can use our calculator's brains, right? 318 divided by 6 comes out to a nice and even 53. So the mean for this problem is 53. All right, so now we want to find the median. The median, remember, requires us to list our values in order, either descending or ascending order, so in order from least to greatest or greatest to least. So let's go ahead and put them in order. So let's start with the least and go up, so least to greatest. So our lowest value is 24, then we have 37, 37 again, 48, 77, and then 95. So since we have 6 values here, our median doesn't have a single value right in the middle because we're looking for that middle number. So since it doesn't have that middle number, we take the middle 2 numbers. The middle 2 numbers in this case are 37 and 48. So what we do with these 2 middle numbers is that we're going to take the average or the mean of these 2 numbers. So we have 37 and we're going to add 48 and we're going to divide by 2. So we'll add 37 to 48. This will give us 85, which we're dividing by 2, and this will give us 42.5. And that is our median. So that's how you can find the median when there isn't a very clear center number, when you have to find it between 2 numbers. So that's how you can find it when you have to decide between 2. All right. Then our next one is that we want to find the mode. The mode is just the number that appears the most often. So if there's a number that appears more than once, that would be our mode. If it's a tie, if like 2 numbers show up, 3 times each, then you would just list all of them, however many show up that number of times. Or if there's none, you would just say none. If they all show up just once, you would say none in that case. It has to show up more than once to be the mode. But so if we look at our numbers, right, 37, 48, 77, 37, 24, and 95, 37 is the only one that shows up more than once. So 37 is the mode. All right, now our next one is the mid-range. The mid-range is a kind of like a technique to try to estimate the mean very quickly without putting in as much work. So the way that the mid-range works is that you take the highest number and you add it to the lowest number and you divide by 2. Or you add lowest to highest. The order in this case doesn't matter since you're adding the values. So we would say our lowest number, right, is 24. Our highest number is 95. And then we're dividing that by 2. So we're essentially just taking the mean of the highest and the lowest number. So we add those together, 24 plus 95. That would be 119, which we're dividing by 2. So you can put that into a calculator or brains, whatever. And this will give us 59.5, which is not that close to the mean. The mid-range is not a very good way to measure the average, but it is a quick way, and that's why it's used, because it's quick, not average, or not accurate. All right. So the last thing we're going to do is we're going to do standard deviation. And standard deviation is a long one to calculate. But we're going to go ahead, we're going to do it. So standard deviation, the first thing that you want to do, and there's a list of steps for standard deviation. So I would encourage you to go back to the section where we learn standard deviation and look over those steps if you do not remember them. But the steps for doing standard deviation, your first step is that you would find the mean. We already did that, so we don't have to do that in this case, right? We said the mean was 53. Our second step is that we are going to subtract the mean from every value in our set that was given to us. So our values, right, 37, 48, 77, 37, 24, and 95. We already have them in order when we listed them in the median, and I like to keep them in order, so I'm going to write them in order. But we're going to subtract. So we have 24, and we're subtracting 53. And then we have 37, and we're subtracting 53. Then we have 37, and we're subtracting 53. And we had 48, and we're subtracting 53. And we had 77, and we're subtracting 53. And we had 95, and we're subtracting 53. So that was step 1. Step 2 is to subtract the mean from every value that you were given. And then you're going to find that value from subtracting. Right? Calculators are brains. Any way that you want to do it, you want to subtract these values. So 24 minus 53 is going to be negative 29. If something is negative, you want to leave a negative. Then we have 37 minus 53 is negative 16. That'll be twice since we have 37 twice. 48 minus 53 is negative 5. 77 minus 53 is 24. And 95 minus 53 is 42. Now your third step, what you're going to do is that you're going to take every one of those numbers that you just got from step 2 and you're going to square them. You're going to raise them to the power of 2. And if they're negative, right, you want to make sure that you have parentheses around the value because you want that value should be positive because you want the positive value. You're trying to find the average distance, the spread of numbers. And so that distance should always be positive. It shouldn't be negative. And so we want to only deal with the positive values. So when we square our negative numbers, right, they should be positive. So we want to make sure we have a parentheses. We want to make sure those values are positive. So we're going to have negative 29 squared, negative 16 squared, which we'll do that twice. Negative 5 squared, 24 squared, and 42 squared. This one you will most likely need a calculator for most of these. And we'll go ahead and we'll calculate what these equal. So negative 29 squared is 841. Negative 16 squared is 256, which once again, we get to write twice. Negative 5 squared is 25. You may have known that one. 24 squared is 576. And 42 squared is 1,764. All right, so we have all these values now. What we're going to do is we are going to add all of these values. That is our step 4. We're going to add all of these. So we're going to add all of our values together. So that's going to be 841 plus 256 plus 256 plus, next line, 25 plus 576 plus 1,764. And we're going to get this equals. This equals 3,718. All right, so we got that value. We summed up all of those values there. Step 5 is that we are going to divide that number that we got from step 4, 3,718. We're going to divide by n minus 1. N is the number of values you started with. So if we go up here, right? 1, 2, 3, 4, 5, 6. There were 6 numbers. So we're dividing by 6 minus 1. 3,718 divided by 6 minus 1, which is 5. 3,718, woo, divided by 5, which is equal to 743.6. Now, technically this value is called the variance. Solving at this point is the variance, but we're trying to solve for the standard deviation, and the standard deviation, aka the last step here, is the square root of the value we got from step 5. So it's the square root of 743.6. We're going to round this off. We're going to do 2 decimal places in this case. So this will be 27.27. And that is our standard deviation. Woo, barely fit that in. So standard deviation definitely has a long technique. There are a lot of steps. There's 6 steps here. If you do not remember how to do them, those could be things that could be helpful to know, before the exam, helpful to go over, in your past lectures and whatnot. Definitely something to review. But there we go. So we went over quite a few things. That was the mean, median, mode, and mid-range, and we did standard deviation as well. So, all right, going back to our main slides here, that does wrap up our review. So hopefully you find that was helpful. Hopefully that can give you some inspiration for studying and whatnot. So good luck on exam 1, your unit 1 exam. So good luck, everybody. Good luck studying.